Hello and welcome back to our discussion on factoring trinomials of the form x squared plus bx plus c. We are continuing to do some exercises to build our understanding of how to factor trinomials. And remember, for this case, the coefficient in front of the x squared is just 1. So we're just saying x squared plus bx plus c. So let's continue on. Okay, remember from our rules, we have to first think about the things that multiply together to give you c. So the things that multiply together to give you c include 1 and 10, or 2 and 5. Okay, so now the next step would be to open up parentheses. And since for this set of problems the coefficient is 1, place just a simple x inside so that when you FOIL, you would get the x squared back. Alrighty, now mentioned as before with our signs, the sign of c tells us what to do. Since the sign for c is positive, that tells us to write in both sets of parentheses right here beside the x's the same sign of b. And notice that b is positive because of positive 7. So that means write a positive in each set of parentheses right there. Okay, now we have to think in terms of adding the things that multiply to give us 10 and what they add to give us the term for b, or add to give us 7. So we know that these will be positive just like they are. So if we add 1 and 10, we get 11. That won't work because we need 7. If we add 2 and 5, that will add to give us 7, so that's what we'll use. We'll add 2 here and a 5 here. Now it's important to note that since these were both positive, that it did not matter what order we stuck those in. We could have put the 5 here and the 2 there. It does not matter. Okay, and let's look at number 6. Okay, number 6. Again, let's start off by listing the things that multiply to give us the c term, the negative 10. So again, 2 and 5. Let's start by opening our parentheses. Just as before, put x's in there. Look at the sign of c. If you notice, it is a negative. Negative means we need to put a plus and a minus, just like we have done in the previous video with examples with negative values for c. Okay, and remember, now since we have a positive and a negative, we have to refer to our sign rules. Sign rules tell us to look at the sign of b. In this case, it is a positive, so that means the higher of the two values being added will need to be positive. So that means that one will be negative, one will be positive. So the lesser of the two will be negative. And in each case, that will be a negative because it is less than 10. And this 2 will be a negative because it is less than 5. Now we have to add these to see which one will give us 3. This will give us 9. We can't use that one. But if we add negative 2 and 5, that will give us a positive 3 because 5 minus 2 gives us 3. So just plug in according to the signs. So where there's a positive, we'll put the positive number, or the 5. And where there is a negative, put the negative value, leaving the negative right there. So that was how you would factor one that looks like that. Now, let's talk about some other examples you may encounter when factoring trinomials of the form x squared plus bx plus c. Okay, so for this kind of problem, we are being asked, is this factorable? Can you break this down into the two sets of parentheses, each with an x and a sign with numbers in for those blanks? And to do that, we have to go through our same process. Look at c. Look at the things that multiply to give you c. 37 can be broken into 1 times 37, and that is it. And looking at the sign of c, that tells us to put positives in because we did the same sign as the sign for b. Since that is positive, we put pluses in each set of parentheses. Now we have to see what things that multiply to give us 37 that add to give us 9. And if you look, since 37 is a prime number, it can only be multiplied by itself to get the product of 37. So 1 plus 37 gives you 38. That is not 9. So this is not factorable. And that is the answer for that. Okay, now you may encounter something a little complex looking like this. It says factor. Okay, for something like this, we have to start by looking at these in the case of this. Just as before, we have x squared starting off, so write an x for each of those, for each blank there. Okay, and using our sign rules, C is positive, so that means use the same signs as B for each set of parentheses. That's positive, so write a plus in for each set. Think of the factors that add to give you multiply to give you 45. That would be 1, 45, and I believe the next set would be 5 and 9. And since these are both positive, we do not have to worry about minuses in this case. So let's place a 5 here and a 9 there. Since y squared is in the last term, the last position in each set of the parentheses here and here also need to include the y to make sure that when we FOIL out, you get the xy for the b term and the y squared for the c term. Okay, and next you may encounter something that resembles this. 3x to the 7th power plus 24x to the 6th power plus 21x to the 5th power. Now, as you want to begin working with this, you can see that 3 will divide into each set of these. 3 will divide into this 3, into that 24, and that 21. So first, pull out the 3. And as you notice, they each have the same variable inside. So let's pull out an x. And remember, we want to pull out as many as we can, but we have to pull out the least number, so we'll pull out the 5. We pull out the 5. We can now factor out this trinomial a little bit more, make it a bit nicer. So we say 3x to the 7th divided by 3x to the 5th. The 3's will cancel out, leaving an x to the 2nd power because we just used the quotient property to subtract the 2 whenever we divided. Okay, plus 24 divided by 3, that is 8. And when we say x to the 6th divided by x to the 5th, we're just using the quotient property to get x to the 1st power or just a plain x. And finally, 21 x to the 5th divided by 3x to the 5th. The x to the 5ths both cancel, leaving us with 21 divided by 3 or just a positive 7. So, sorry you couldn't see that problem all the way. So this is what we're left with. As you can tell, this term can be broken down even farther. If we look for the factor, or the things that multiply, to give us 7. Well, 7 is prime, so it can only be multiplied by itself and 1 to get back to the product of 7. We're not working with any negatives, so both of these will be positive. Again, we write the x to the 5th, and then let's break it into 2 sets of parentheses. We know that the x squared tells us to write x's for both sets, and since we have positive signs throughout, we write the positives there. Using our only set that multiply to give us 7, we look to see if we can add them to give us the 8 or the b term, and as you can tell, 1 plus 7 does yield 8, so write a 1 and a 7. And if you were to FOIL this out, you would get back to the original trinomial.